What's up guys, it's Minx. In the last video we got an auto camera set up. There was a mistake I made with it, not a major mistake, it still worked, but something didn't happen, or we didn't use something. So by default technically auto move camera doesn't, or the toggle auto cam doesn't actually get really used. I think it does, okay it does get used. Um, but we don't actually use the bool that it sets, we don't actually use enable auto cam. Um, So we can go where this is referenced. So if we click here and go to on update, we can say if, oops, if this dot autocam, and we don't need these little, we don't need the curly braces. We can just tab this over. C Sharp's got that little cool thing in the newer versions where you can just tab this over. Um, so we've got that. So now if autocam and autocam's not enabled unless we set it to enabled, otherwise it would be running it even though we didn't enable it. And what would happen is if we didn't toggle it and it was set to true by default, or like something else set it to true without toggling it, for example, they use like reflection to access this, um, then that would bypass what we need to do and it would cause issues. So this fixes that. Simply says, hey, if AutoCam is not enabled, we don't do it. Now, if someone goes in and it affects the bool anyway, then it is what it is. But anyway, so right now I've actually removed the floor. So I mean, you can't really tell that the player's moving or not, up and down. But if we go to on start here, on load, I've commented out the floor. I'm going to leave it in as a comment because we may put it back later, or when we're working today, we're going to copy some of the data over from this. But in this video, we're going to go ahead and learn how to load levels from objects. So we're not going to like, well, we'll kind of have like a basic object created, but we're going to like create the way that the level will load from that object. So we're going to have a level block, and we're going to load the level, and then for each level block in that level, we're going to spawn it where that level block says it needs to spawn. So it's not super complicated or anything, but it is interesting because we use some principles. We use some principles that we've already used in this project, but we also apply them in different ways that are kind of interesting. So the first thing I want to do is go ahead and create like the what we're going to be pulling from, so like the level object and the level block like objects for it. So let's go into our game folder, add a new item, and I'm just going to call it level. We don't need to like specify it's like, hey, this is level, and make a new file for level block. No. So we have level. Then we'll do a new class in here. We'll also make it internal. I don't really think it matters that much. Level block. So level can store metadata about the level. So for example, we can do, I want to make these public because other things will need this information. In fact, this may even be able to be like a struct or something, but we'll leave it as an object. So like, for example, a public string game version. And for now, it's not gonna have anything. We can say like equals 1.0. And I'm gonna put a comment in here, unused for now, but in the future could be used just to load levels from old version of game. So for example, if we update our game to 2.0 and our level load map is different for the 2.0, we could go in and say, hey, this is level load map 1.0. Use these instead of our new version to load this. That way, the level doesn't load with wrong objects at the spots it wants to load things. This way, it doesn't break old levels. This is sort of a backwards compatibility thing, but for now, we're not going to do anything with that because we don't have to worry about it. And technically, if our game updates in the future work the way that we intend on them to work, we should have um, a backwards compatible system anyway, just old levels won't have new features. But we'll see. Some things happen, right? So we're gonna make a new before we can actually make the new thing. Actually, no, we can because we already have level blocks. So we say public list of level blocks, and we just say I'm gonna call them level contents. Level contents equals, and we're gonna instantiate it because we need this immediately, at least for our testing. So when we create a new one, we say, hey, make this, and then we're going to populate it. So we could say like populate, dot add or whatever, but we'll leave it as just its own thing. And that's pretty much it for level for now. We'll definitely come back here and probably add some more stuff. Like for example, maybe the player spawn is separate, or maybe it's a specific point on the map or something like that. Anyway, level block. So level block is just a couple things. So we got public vector2 location and public string identifier. And I actually want to do a constructor on this one. So we'll say public level block. And it should pre-fill it. Like if you do this, it should give you this if you're in Visual Studio. If it doesn't, that's okay. You can type it out. We just want a constructor that when the level block is created, we want to assign it, hey, this is the location identifier. That way when it's created, because we'll be creating it programmatically, it won't be like, I mean, it'll be read from a file at some point or something like that. But if we're writing it from code or loading it from like a JSON file, that's probably what we're going to be using for these as JSON files. It will very likely be it'll be created programmatically. So when we create these, we need to identify this information. And as far as the level block goes, when it's as part of a level, instead of saving all the information about our particular block, like this level block has this brush, this level block has, this particular size, this level, well, size will be, we'll talk about that in a little bit. This level block has this particular attributes. No, we give it an identifier and the game has predefined this information and we map it out. And that's what we'll be doing next, essentially. So we've got level block and level. That's pretty much it for this side of things. Let's go back. You can actually close out a level. And test object is going to be important. So for our testing, we're going to use test object, which is nice. So how do we map these things out? It's it's not that weird. It's kind of interesting. So let's go up to the top and let's sort of make our load level map or level load map, whatever you want to call it. So we'll come right below AutoCam and say private dictionary. I don't think we need anything else to access this. And the two things are going to be, so we have a string for the identifier, which is what comes from the, I just closed that level, comes from the level block. So we got the identifier. And then the other thing is, what is this thing that we're trying to load? And we can't just say, hey, we're trying to load test objects here, because we're not just loading test objects. We could do like a derivation based thing where it's like, hey, we want to load this from a level piece or something like that everything that gets loaded and derives from. But we could do something a little bit more generic that helps. For example, enemy spawner and wall may inherit from different things, and it's kind of hard to get them to like, hey, a tree of inheritance that kind of just gets ridiculous. So instead, what we'll do is we'll say type and make sure it's capital T. And this will say this is the type of the object we're trying to load. And we'll just call it load level map. So what happens is we pass in an identifier and it'll return a type, and then we instantiate an object of that type with the settings based on the reference from level, which says, hey, this is the identifier, here's the location, instantiate an object of this type based on this identifier at this location, and let that object handle the rest. So level's fairly generic because of that, and it makes it a little easy. Instead, what we could do is like go into like a file and say like level pieces, going back to that level pieces, we make a test object. Here is level piece 1. We're gonna make a new class. Here is enemy spawner of this type, spawn this here, with this identifier, whatever. So let's go into onload. I think this is probably the best place to put it. It's like onload, we set up our level map or whatever. So we'll say load level map equals new dictionary of string type, and we'll do our open braces instead of a parentheses. And in here, the way we do this is it's just like any other thing. It's not too different. We're just going to use A for this one. We could use different identifiers later. A doesn't have to be anything specific. And we want it to be a test object. Now this is going to toss an error already. We see that test object is a type, which is not valid in the given context. You'd think that would, that would make sense, or that doesn't make sense. It's a type. We are using type. So there's type. This is a type of class, and then there's the actual system.type. So what we need to do is use the type of keyword, put this in parentheses, and it'll get the actual system.type of test object. And we can use this to go back later and say, hey, I want to create instances of this system.type. That's probably the best way I can explain it. So for now, since we're only going to be doing since we don't have the test object, we could add more stuff later, but we'll do A is type of test object. So now we know if we try to spawn something, we can do that. Let's go ahead and create our actual level load function. And it's actually super simple because the actual hard part is giving the information to level contents. With the level contents as the correct information, we just have to pull that data and do something, which we already know what we want to do. We just want to spawn it, and the game's already saying call load to instantiate this object, and the object says I want to be drawn, I want to be I want to be a dynamic object, so I want to have collision or something like that, stuff like that. So let's go ahead and come down here, and we're gonna make a new. This is gonna be private for now. It may become public if we need to, but it can be private level. And load level is gonna take a level to load, so we'll do level, which is the name of the class we just made, lowercase for the variable name. And what we want to do is, so if we go back to level, we want to say, okay, so we have level. We could do something with game version now or something, but we definitely, since we're loading level, we want to get access to level contents. And since it's a list, we want to say for each level block, we could just do level block lowercase l with capital B. So each level, or we'll say block actually, make it a little easier. Level block in level to load. Oops, or level, excuse me, not level to load. Level contents. And this is where I actually struggled myself because I tried to say, okay, just treat this like a type and instantiate the type, and it was difficult. It was like I had to go through, read some stuff about some things. I looked at reflection and stuff like that, and I came up with well, okay, I didn't come up with it. I found something that worked. So we have something called activator create instance, and we don't want to use the like open close less than equal greater than signs. What we want to do, because that uses a parameterless constructor, which we don't have a parameterless constructor, and it doesn't work anyway, considering we're pulling it from a dictionary, which is actually what made things a little difficult. Instead, we want to use the create instance as a normal method, and type, we can just toss in load level map with the type of block.identifier. So if the block's identifier is A, it will go into this dictionary and say, where's the dictionary on load here? It'll say A, so the string that we have in there is A, point to type of test object. And this should just turn into load level map. Or excuse me, not load level map. It doesn't say it here, but it points to what we need. Now, this could work. However, it's going to toss an error because if we go to our test object, we have a couple things in our constructor. We need to pass in the game, the position, and the scale. So this is probably going to be standard, probably, because we need to tell it what to do. We need to register it, and then we need to tell it its location and scale to spawn, and it will handle everything else. So that's okay. We'll give it the information it wants, and that's probably going to be what we're going to have to do for every single object that we spawn. So to send that information through, we have to make a new object, and it'll be an array. And this will tell us, hey, these are the parameters. Because if we look at create instance, it says params object args. So that's pretty cool. And first object is, or our first parameter is this. It's the game window. Our next one is the location. And we have location defined in block, so we can actually say block.location. One thing I didn't do with the block is give it a scale. And the reason for that is we're going to have a grid. So it's going to be a grid where it's like, hey, you have a set look like each place is a set location. So you say, hey, 0, 50, 100. I think it's going to be 50 instead of 100 wide because 100 is huge. But we're going to be doing, we'll do 50-50 here actually because we want to make sure we set this up for future reference. We could change this, maybe remove the hard coding, pass it through somewhere, but for now, this will go in and create an instance of these. And since now we don't have like a specific object reference to these, like we don't say A equals activator dot, no. We tell the object to spawn and the object registers it. So even though we don't have a specific reference to this object, it's in a list that tells it what to do. So we don't need to do anything else. We don't need to like do anything else. Or yeah, I just said that twice. We don't need to go in and do a bunch of extra stuff with it. This will literally load our level from our class. Now, the only thing that's left to do is populate the class with something. Later down the line, when we use like, so for example, I'm thinking a level object is going to be pulled from a JSON file. So, we serialize the level. When we create it, we serialize it to a level file, save it, and be done with it. And then when we want to load the level, we deserialize it into memory, into this class with level content classes or objects, excuse me, and we just load it from that. So we'll probably just be doing that. And this way, this allows us to save metadata easily. And it's a little different than like saying, because when you normally do something like this, like I've seen this in Pygame, I've seen this in JavaScript, you do something called a 2D array and you load it based on that, which works, but it doesn't work. It's not a good long-term solution in my opinion. Instead, telling each block, its information that it needs to store this way gives us a bit more control down the line if we want to change things up. Maybe we don't want it to be 50-50. Maybe we want the identifiers to change simply. Maybe, other stuff. It's easier to do it this way, in my opinion, in the long run, even if it's a little bit more difficult to set up in the first place. So let's go ahead and go into game state. And again, just like for testing, because we haven't got like a menu set up or anything, we don't have like a way to like select the level to load. We just have this onload function that says, all right, everything's set up. We can do a new thing. We'll make a temp, we'll say var level, or we'll say temp level equals new level. And level doesn't have anything in the constructor. So what it does is when we create a new level, there's a default constructor that we can't see. It calls new level and list is created. So now we have access to this list. What we can say is for each, we can actually, not a for each, a for loop. We could actually take this for loop, copy it over out of the comments. So for I listens this, and we can comment out this discard. We can say temp level dot level contents dot add, and it's going to take a level block. So we'll say new level block. And if I'm not mistaken, level block has a constructor, right? With a location and an identifier. So location's first. Location is going to be, we'll take this new vector2. Oops, I didn't mean to do that. Copy the vector2 over. And then identifier, we know we want it to be a list of A's. So we're going to do that, or well, an A for the identifier. So temp level is created. We populate temp level with a bunch of, we populate level contents with a bunch of level blocks at locations based on I, which is going to do the same thing. So it's going to take, 0, 100, 200, 300, 400, 500, etc. And actually want to do 0 or I times 50 because the width of it is 50. We'll have to change this stuff later to make it a little bit more based on this. We do this rather than hard coding things. And I'm going to make it 40, so it's going to be the same distance. But anyway, and actually we'll do 670, so it goes to the bottom of the screen. Just completely align everything properly for later. So it adds it to the list. Now we need to actually tell it to load it. So we would go in and say this.load level, and it would be temp level. Okay. Temp level standing for temporary level because we plan to remove it. But that should actually be it. So we hit start here. See if we get any errors. Looks like we've got, so a little high, but it is what it is. Oh no, it's not high. It's because the camera's moving. Okay, that's right. I'm like, why is it so high? But no, it's good. So it is now creating our level for us. We could like manually do things like say temp level dot add, and we can, just copy this logic over. So we want a new, we'll say about halfway through. So we have 40 of these. 40 times 50 is, it's 2,000. So we'll say 1,000. And we want the height to be, we'll do 620, just for an example, just to test it out. Oops. Oh, temp levels.level content.add, excuse me. We're adding it directly to the object. There we go. So we should get about a cube halfway up here. Yeah. So very cool. Okay. And I guess really quickly, I mean, this video is 20 minutes long. Let's go ahead and really quickly create a new, uh, we'll put it under test object. We'll call it like test object 2. Hey, internal class test object 2. And we'll derive, we'll derive from iDynamic. We won't derive. I was thinking maybe we just derive from test object, but I don't really feel like doing that right now. So we'll kind of just, we'll copy the class over. And maybe in the next video, we'll set up inheritance like this so we can create like level object and then do different things based on that. And all we're going to do is change the brush. We're going to make this one red. And then what we'll do is we'll go over to game window. We'll go into here and we'll say B is equal to test object 2 instead of test object 1, or just test object. So what this can do is we say, okay, when we create this one that's outside of the for loop, we'll put a B instead of an A. If we start, now we have a red cube instead of a blue one. So I guess that's pretty cool. It gives us a setup, so we don't have to do like if identifiers this, do that. No. It's the same principle with the dictionary that we did with like input mapping, stuff like that. We map it so that way we don't have to do a bunch of if statements. I actually learned this with so there is a unique thing or maybe a cool trick that C does, not C++, pure C, does with switch statements, where if you have a long list of things, so like 5, 6, 7, 8, 9, 10 plus things, maybe 20, if your thing is towards the bottom of the if statement, so like towards the end, so you have like it's at the 18th and it has to go through all the if statements, a switch statement is actually faster because it does some real cool like math trick to go faster or like get to that point rather than just going through all the if statements. And that's kind of, I mean, it's probably not the same going on under the hood here, but it's the same principle. I think it looks better, it feels better, and I'm hoping, at least to a degree, there's some sort of at least um, performance gain. Maybe we are using up a little bit more RAM to do this, but I think it's insignificant compared to having to do a billion if checks every single frame. So anyway, that's it for this video. In the next video, I think we'll probably look at adding some more objects. I think I wanted to clean up. Yeah, we'll do some object inheritance. So instead of inheriting from um, a bunch of like iDynamic on a bunch of separate like test object 1, test object 2, and then copying and pasting the same code. What we'll do is we'll use the base object and we'll inherit from it. So this will have the default behavior, and then these other ones will override that behavior. So thank you for watching and have a wonderful day.